Kia ora koutou. This is my third go at trying to make this video. The first two goes have been interrupted by snoring dog, drums, dinner cooking, and stupid comments from people in the kitchen. So this time I am going to get it done, but there might be some background noise. Now there are two parts to this. The first part is really boring, but important that you know it. It's the trapezium rule. And it's the trapezium rule where I haven't been given the formula because it's A-level, and I also haven't been given the numbers in between or the table, so we have to do a bit of working out. It's boring, but I want you to watch it. The second bit is a really tough integral problem where we've got to then find the exact area of R. Now there was another question in here where you had to compare them and work out the percentage error, but I've left that bit out. So in the first part, we're told that we need to use the trapezium rule with 3 intervals to find the approximate area of that's shown. So we've got 1 here and 4 here. So it's pretty easy. We're going to whack in 2 extra values at 2 and 3, and that means that my width, h, is going to be 1. The formula for the trapezium rule is this. It's going to be that width of the interval halved, and then I put in my 2 endpoints once, and I put the other bits in the middle in twice. So in this case, I've got 4 y values that I need to figure out, and that's the first thing that we're going to do because we haven't been given a table. So let's do a nice table. Oh, wow. It's good when the OneNote does that for you. Right, so the y values are going to be 1, where's it gone? 1, 2, 3, 4. I'm just going to pause the video so you don't have to watch me working these out on my calculator. Okay, so that got rid of some of the boredom for this question, hopefully. So then A is equal to 1/2 times this one and this one in there once. So 0.5 plus 1.333 plus 2 times this one here and this one here. Now, when I put all of that together, I got 2.84317, which is 2.8423 significant figures. Okay? So that's the first bit done, pretty easy. And now this next bit, we have to find the exact area of R. Now, if you look at it, it looks like it's going to be substitution, and it is substitution, but then it's still a bit tricky even after the substitution. So let's see what we're starting with. We've got the integral from 4 to 1 of x over 1 plus root x dx. So I tried this. I said, well, let's make u. I looked at it first, and I don't have a nice log thing going on or a basic polynomial. So let's let u equal root x, which is x to the 1/2. That means that du by dx is 1/2 x to the negative 1/2, or 1 over 2 root x. I'm going to need to somehow get rid of the dx, get that in terms of du. So that gives me this. 2 root x du is equal to dx. I don't want to have this in terms of x. This is 2u du is equal to dx. Right, so that's going to be the first thing that I sub out, and then this has also got a u that I'm dealing with. The next thing that I do, as usual, is I'm going to look at my limits, and I'm going to get those in terms of u. And none of this is too hard so far, right? So we've got x here is 4 and 1, and u is equal to root x, which is 2 and 1. What does that give me? Well, that means that this, I, is equal to the integral between 2 and 1 of 2u over, what's 2u, and then this x here is u squared, right, over 1 plus u du. So cleaning that up, we get this. We'll pull the 2 out the front, and we've got u cubed over 1 plus u du. And when you stop and look at that, I don't know, but I didn't feel that good, right? Because I've got 1 plus u here, and then I've got a cubic thing up here. So what we have to do is the thing where we're going to force out some multiples of 1 plus u. If you think about it, just to get us started, what we can do here is to say, well, that u cubed is equal to u squared times 1 plus u minus u squared. And that should give you a clue about how we're going to do this. We can keep on going in steps here, or we can simply say this. How many times does u plus 1 go into u cubed? And if we do polynomial long division on it, we're going to quickly get a bunch of terms that have 1 plus u as a factor. So we're factorising out the denominator, which is 1 plus u. So let's go slowly through this. I'm going to have u squared to match up the u cubed. That gives me u cubed plus u squared. Subtracting that gives me negative u squared. Now I need to have minus u here, which gives me minus u squared minus u. Subtracting that gives me a plus u. And I get u, let's see, what do I get here? I've just got u here, and then u plus 1 here. So that gives me negative 1 remainder. So all of that means the following. It means that I can write u cubed as u plus 1 times u squared minus u plus 1, take away 1. And that is going to help me enormously with my integral. So let's go back to the integral, and we're going to ditch this bit here, and we're going to rewrite the u cubed. Okay, so the u cubed is now u plus 1 times u squared minus u plus 1 minus 1 over 1 plus u du. Just get rid of this off to the side. And this suddenly becomes a really easy integral to work with, because here, this and this are going to simplify away, and I get u squared minus u plus 1 minus 1 over 1 plus u, which is also a really easy integral. So that gives me, for my final thing, I'm going to have 1/3 of u cubed minus 1/2 of u squared plus u minus the natural log of 1 plus u, evaluated at 2 and 1. So when I put all those values in, what I was really hoping that I was going to get a number very close to my trapezium rule, because the trapezium rule is probably going to be a pretty decent approximation here. So substituting in 2, we get 2 cubed 8, 8/3 minus 1/2 of 4, which is 2, plus 2 minus the natural log of 3, minus 1/3 minus 1/2 plus 1 minus the log of 2. And when you work all of that through, happily, we get 2.855. So how cool is that? Look, so my value here is 2.86 to 3 sig fig, and my value with the trapezium rule is 2.84. And what I want you to see is why the trapezium rule is an underestimate, because it comes back to the shape of the curve. So let's go back to that graph. Now, the graph it looks like it's nearly linear, but it's a very, very tiny bit. Oh, well, I think it is. I think it's going to be, the reason the trapezium rule is slightly under is because you can see a tiny bit of curving through there. If you go into GeoGebra and have a look, you can make sure that I've got that right. Okay, so quite a long video, but there's quite a lot in here that I think is really good. Now, I don't think that was an A-level Cambridge question. I think I stole it from somewhere else, but I can't remember where. It's completely within the curriculum, though, and so it's possible that you would get that as one of the harder questions in the paper. So definitely worth getting really confident with the step that came after the substitution in here. Thanks for watching. Keep on firing in your questions.